What's up everyone, Patrick here, welcome back. Moving on to another example dealing with quadratic equations. So we have to solve these equations over here. And notice that all of these equations, there's a mixture on both sides of the equal sign. So quadratic equations that we solved in the previous videos, they were all, for the most part at least, already all on one side, and then we had 0 on the other side. Here, there's a mix. And if you remember, what we want to do is we want to try to get everything to one side in order to have the equation be in this kind of format where we end up with a quadratic equaling 0. Then we can go into solving it in different ways. In this particular video and over the last few videos, we've been solving with factoring. So that's still going to be the method here, but with these, there's going to be some preliminary steps to bring everything to one side, get it in that format right there. So let's start off with part A. We have 3x squared equals 11x plus 20, like this. So what I'm going to do, take these two terms, bring them over to the left side. So we'd have 3x squared minus 11x minus 20. And then we'll have equals 0, right? They're positive here, so when we bring them over, it becomes negative. And then from here, first thing we always check, can we take out a greatest common factor for 3x squared minus 11x minus 20? Notice that we can't. So let's see if decomposition would work. So the a value is 3, the b value is negative 11, the c value is negative 20, the ac value would be negative 60. So are there two numbers that multiply to negative 60 and add up to that b value of negative 11? And those two numbers would be what? Negative 15 and 4 works. Negative 15 times 4 is negative 60. Negative 15 plus 4 would give us negative 11. So then we just decompose. Sorry, that's plus 4x. That middle term, then we could take out a 3x, so it would be left with x minus 5. Then we could take out a 4, x minus 5. And we could take out an x minus 5, and we're left with 3x plus 4, like that. So this quadratic factors into x minus 5, and then 3x plus 4. And then that's going to be 0 like this. And then, remember, how can this left side equal 0? Well, basically, either when this bracket is equal to 0 or when this bracket is going to be 0. So this is going to happen at an x value of 5. This here is going to happen when 3x is negative 4 or when x is negative 4 over 3, like that. So those would be the two solutions for part A. And if you want, you can check your solutions. What you could do is you could take both of these, plug them in to the x values you plug in here, and then make sure that the left side is equal to the right side. So for example, if we plugged in 5, we'd have 5 to the power 2, which is 25 times 3, we'd get 75. And then notice that if we plug in 5 over here, 11 times 5 gives us 55 plus 20, we'd get 75 again. Right, so left side would equal right side, and then with negative 4 over 3, if you did the same thing, you would see the left side would equal the right side as well. So that's how you could do a check. Moving on to part B, we end up with 8x squared. So let's actually, you know what, let me just write it all out. So let's bring everything over to the left side. Usually the side that I bring everything over to is the side that's going to make the leading coefficient positive. So notice that there's no other x squared term, and we have a positive 8x squared, so it's already positive here. So let's bring everything over to the left side. But let's say this is like a negative 8x squared, then I would bring everything over to the right side. But in this case, it's already positive here, so we'd have 8x squared minus 2x. Negative 29x, that would be positive 29x. Negative 22, that would become positive 22. And then we'd have equals 0. Like terms over here. So that would be what, 27x? And then we'd have plus 22 equaling 0, like that. And then from here, greatest common factor. So let's try to factor this. Just to give myself some room here, let's write this up here. So notice we can't take out a greatest common factor from this quadratic. So let's see if it will factor with decomposition. So notice that the A value is 8, the B value is 27, and the C value is 22. So the AC value would be 176. So then what we want to see, are there two numbers that multiply to 176 and then add up to 27? And if you try it out, those two numbers would end up being what? 11 and 16, I think. That would work, right? 11 times 16 would give us 176. 11 plus 16 would give us 27. So then what we could do, we could take those numbers, decompose this middle term. Like that. And then from these two, we could take out an x. From these two, we could take out a 2. And then we could take out an 8x plus 11. And we're left with x plus 2. By the way, you may have different methods for factoring. You may not be doing decomposition. Whichever way you're doing it, just make sure that when you're factoring the quadratics in your method, you're getting the same factors that I'm getting. So this left side here factors into those two. And then we're solving an equation, remember, so when does 8x plus 11 equal 0? When does x plus 2 equal 0? Well, this is going to happen when x is what? Negative 11 over 8. This is going to happen when x is negative 2. So those would be the two solutions to part B. So that's going to be x is negative 11 over 8. And then this is going to be when x is negative 2. Part C, we got 6x squared equals x. This one's actually not going to be too bad. So we're not going to end up having a C value for the quadratic when we bring everything over. Let's just bring the x over. So we'd end up with 6x squared minus x is equal to 0. Then notice we could take out a x. And so when is this bracket going to be 0? Well, basically when just x is 0. When is this bracket going to be 0? We bring the 1 over, divide both sides by 6. Basically when x is 1 over 6, like that. So x is 0, x is 1 over 6. Moving on to part D, which I wrote out over there, we got x squared minus 4x equals 9x squared plus 25x minus 12. So notice that in this case, we have a 9x squared over here, and then we have an x squared over here. So I'm actually going to take everything, bring it over to the right side in order to have a positive leading coefficient or a positive a value for the quadratic. Because if we bring this over, you can bring everything over to whichever side. You're still going to get the same solutions in the end. It's just then you're going to be dealing with a negative leading coefficient. Then you got to worry about taking out a -1 when you're, or before you do the factoring by decomposition. So personally, I'm just going to bring everything over to the right side. So we'd end up with 9x squared plus 25x minus 12. Bring this over, it'd be negative x squared. Bring the negative 4x over, it'd be positive 4x. And notice we got a like term here. Let me actually write out the quadratic equation up here. So 9x squared minus x squared, those are like terms. 8x squared, 25x plus 4x would give us 29x. And we got a minus 12, like that. And then from here, let's see if this will factor. I think it will. First thing we always check for, greatest common factor. Notice there are none. For 8 and 12, there's a common factor of 4 and 2, but notice that none of those is a factor for 29. So unfortunately, can't take anything out initially, so we'll have to work with these bigger numbers here. So we'll have AC equaling, what, negative 96. So two numbers that multiply to negative 96 and then add up to 29. That would be Let me think here. Negative 3 and 32. I think that works. Negative 3 times 32 gives us negative 96. Negative 3 plus 32 gives us positive 29. So those are the two numbers. So then we just decompose that middle term. Sorry, that's minus 12, right? Give me a sec here. Yes. So from here, factoring by grouping, we could take out an x. From both of these, from these two, we could take out a 4. Like that. Then we could take out an 8x minus 3. Then we could take out an x, or we're left with, rather, an x plus 4. So this right side factors into those two values. So we'd end up with 0 equals 8x minus 3 x plus 4, like that. So then when does this bracket equal 0? When does this bracket equal 0? That's going to happen. This is going to happen when x is 3 over 8, positive 3 over 8. This is going to happen when x is negative 4. So those would be the two solutions to part D. So let me write those out over here. While I'm going through this video, maybe you could even pause it and then try these yourself here and then see what I get. You could compare these solutions if you want a little bit more practice. I'm just going to keep it going. So for part E, I'm going to just bring everything over to the left side because we have a 2 and then a 17 for the coefficients in front of the x squared. And I'm just going to do it in one step in this case. So the 2 I'm going to bring over. 17 minus 2x squared would give us 15x squared. Then we got an x here. We got a negative 80x. Bring this over, it becomes a negative x. Negative 80x minus x would give us negative 81x. And then the negative 30 bring over, that becomes positive 30. If you want to write that out in a few more steps, feel free to, but the final quadratic equation format you should get is this right here. And then in this particular case, I feel like we can factor. What can we take out? We could definitely take out a 3 from this quadratic, right? So let's just work with the quadratic for now. Let's forget about the equation just so we don't have to keep writing that 0. So the greatest common factor that we could take out here would be a 3, and we'd be left with 5x squared minus 27x plus 10, right? If we divide all of these by 3. And then let's see if we could factor. Let's, you know what? I'll just write this quadratic over here. Let's see if we could work with this bracket, factor it. So the a value is 5, the b value is negative 27, the c value is 10, the ac value is 50. So two numbers I multiply to 50 and then add up to negative 27, negative 2, negative 25, negative 2, negative 25, like that. So we'd have 5x squared minus 2x minus 25x plus 10, like that. So here we could take out an x, and then from here we could take out a minus 5. So we'd have 5x minus 2, like that. So then notice that we could take out a 5x minus 2, and we're left with an x minus 5. So this bracket factors into those two brackets right there. So we'd have a 5x minus 2, and we'd have an x minus 5, like that. So going back to the equation, this factors into all of this. Right? So make sure you're keeping track of the main thing here, even if you're doing any kind of side work. So notice that the 3 factor on its own, that can never be 0, but 5x minus 2 can be 0, x minus 5 can be 0. And this is going to happen when x is 2 over 5. This is going to happen when x is positive 5. So those would be the two solutions for part E. X would equal 2 over 5. Here, X would equal 5. And then moving on to the last three, so starting with part F, we got x squared plus x equals 42. So let's bring everything over to the left side. So we'd end up with x squared plus x minus 42 equals 0. This is a pretty simple quadratic to factor, so I'll just put the answer straight away. After you do decomposition, that's what it's going to factor to. So basically, when does x plus 7 equal 0? When does x minus 6 equal 0? This is going to happen when x is negative 7. This is going to happen when x is 6. So those would be the two solutions for part F. And then part G, 37x squared minus 45x equals 5x squared plus 3x minus 18. So again, I'm going to bring everything over to the left side. When we bring the 5x squared over, 37x squared minus 5x squared would give us 32x squared. Negative 45x, bring this over, so we'd end up with negative 48x. Then we'd have plus 18 is equal to 0. When we bring the negative 18 over, it becomes positive 18. And then from here, let's factor this quadratic. So let's write the quadratic over here. I think we could take out a 2 to start. Sorry, not the equal 0, just the quadratic. We could take out a 2. Actually, I think this is going to be, yeah, it's going to be a perfect square trinomial. So then this quadratic, let's see if it factors. Let's just work with this bracket now. So the A value is 16, the B value is negative 24, the C value is 9, AC would be 144. I think we've definitely factored this quadratic in previous videos. Negative 12, negative 12. And so it's going to be a perfect square trinomial because those two numbers are the same. So then we would decompose that middle value into those two values. Take out a 4x. And then from here we could take out a negative 3. Okay, I'm going through this factoring pretty quickly, but we've done tons of factoring up until this point. So I'm assuming you're fairly comfortable at this point with this process. So we end up with that. Okay, so let's keep track of what we're doing here. We took this quadratic, took out a 2 initially, and then we just worked with this bracket on the side. This bracket factored into those two brackets. So this quadratic, it factors into the 2 we initially took out, and then 4x minus 3 times 4x minus 3, which is just 4x minus 3 squared. Right, so this left side is going to factor into that. The 2 can never be 0. We have one factor. 1 is 4x minus 3 going to equal 0 basically when x is 3 over 4. So there's only going to be one solution to part G. And then we've seen that in previous videos when you're working with a perfect square trinomial. When that equals 0, there's always going to be one factor because a perfect square trinomial only has one factor, right? And it's to the power 2. Then part H looks a little weird, but this is actually not too bad because we bring the 7 over. And then I think we're going to end up getting a difference of squares here. So notice we could take out a 7. Let's actually do it all in one, like that. And then notice this is a difference of squares over here. That's going to factor into 2x minus 1, 2x plus 1. Like that. Again, I'm assuming you've watched all the videos up until this point. Difference of squares, we've done tons of those examples. So hopefully you recognize that this factors into those two. If you don't recognize that, then I'd recommend going to the section where we covered a difference of squares. So from here, the 7 can't be 0, but when is the 2x minus 1 going to equal 0? When is the 2x plus 1 going to equal 0? This is going to happen when x is 1 over 2. This is going to happen when x is negative 1 over 2. So basically, the two solutions are plus or minus 1 over 2, in this case for part H. Okay, so just a couple of examples where you got to bring everything over to one side, do a little preliminary algebra. Again, get it to that point where quadratic is equal to 0, then take the quadratic, see if you could factor it. Once you factor it, see when the factors are equal to 0, and then you get your solutions or your x values.